Hello students, welcome to your computer science class. Now, I introduced you all to functions. I gave you all a demonstration of a program, simple interest, and even this one. But I am sure there is a lot of confusion. And this confusion will stay because now you all have become comfortable with sequential programs. And you all don't understand why are we to use modular programming. For this, it's very important to understand the advantages of functions. Now let's say, suppose now we're taking the same tent example and we're thinking that this company has decided to design another type of tent whose base is rectangular while the upper part also remains the same. The base is rectangular, it's not cylindrical, but the upper part remains the same. In such a scenario, some function of the existing code can be reused by calling the function calling the function call. So now you always say, ma'am, we can always copy paste it. Yes, you can copy paste it, but it will give rise to different set of problems. Because if you're working in a company, every programmer names variables differently, and understanding what variable did he name or her name will become difficult. But if you name as a function, all the variables inside the function have a local scope. Like I told you all cannot use that variable outside. And when you call for that function, you're just supposed to pass the things required and not necessarily in the same with the same variable name also. I'll give you this demonstration right now. Okay, let's say, okay, so let's say I am using, let's do area of a square. All right, so I say define square, open bracket, close bracket, and I will be taking what do you say, side. We will require the side while doing this. So let's say I'm using S over here, and I'm saying I'm directly printing in this. I'm not sending it back. I'm not using return function to go back. I'm just saying print, okay, and I'm just going to print S raised to. Correct? Yes. So I know S raised to 2 will give me the answer of area of a square. That is the name of my function. Now over here, let's say when I'm taking it from the user, I am saying A equals to input, integer input, sorry. And I'm going to say enter the size of side. Okay. Now when I'm taking from the user, I'm saving it in a variable called A. And when I'm going to call the function, that is area underscore square, I'm going to send the value A. A is my container. A is the variable, and the scope of the variable A right now is global scope. That means inside I can write print the size of side is, and then I can write A over here. I can do this, but I cannot. The reason I'm doing it down is so that my thing will execute right up till here and it will stop here. Okay, it will give me an error over there. Print over here. I cannot use S over here. I cannot say the size of side is and use S. S will only be used inside this function, and A can be used anywhere in this program. Okay. That is, I'm also teaching you all local scope and global scope, which will come a little later. See, enter the size of the square. I'll write 5 and this will go in the alphabet A. It will calculate. It calculated the size 25 also, and it even displayed it to me. It even displayed it. This print s raised to 2 also happened. Then what did not happen? Where is the... Even that happened. Then print the size of side is A. So 5 also came. S is not defined. Can you see S? This is where the error came. But if same thing, this I write over here. And then I will run my program. It works. So the word S can only be used inside the function. Number 1, you have learned that. Number 2, we are sending the alphabet A, which gets converted to alphabet S when inside the function. So transfer of value takes place. The value that was in A goes and saves itself in letter S, then goes in the function and it uses all the variables over here, does the calculation. If I had to return, I could have even used the word return over here. Return. This would also work. But in this, no print statement is there. So it will ask me for the size of side and it will stop. It will even calculate the area of square, but it will stop. It will not give me an output because there is no print statement at the moment in this program that you see on your screens. So I have to take a variable, let's say b, and save the value that I get from the function area of square, and then I have to print the value on the screen explicitly. All right. So over here 5, 25. Now, if I don't do this, still everything happens. Only thing that doesn't happen is you cannot see the final result. To see the final result, we need a print statement. So this was functions again. Now going back to the advantages of functions. So the advantages of function is if the company develops another product or provides services later on where 18% tax rate is to be applied, the programmer can use the function post tax price directly. They don't need to write it again and again. And in post tax price, they can write and they can just send whatever cost they want, even in number format. It will give you back the calculated format. So the user function becomes easy. Thus, the following are the advantages of using functions in a program. Number 1, it increases the readability, especially for longer codes, as by using functions, the program is better organized and easy to understand. Number 2, it reduces the code length, as same code is not required to be written at multiple places in a program. It also makes debugging, that is finding errors, easy. It increases the reusability, as functions can be called from another function or even another program. So we can reuse or build upon already defined functions and avoid repetitions of writing the same piece of code again and again. Work can be easily divided among team members and completed in parallel. So you can all be working at the same time at different parts of the same program. Now, user-defined function, this we have already done, so I'm going to quickly skim through it. Taking advantage of the reusability feature of functions, large number of functions are already available in the Python standard memory. We can directly call these functions like we are already using input, int, print. These are ready-made functions. So we can directly use these functions in our program without defining or creating them. However, in addition to the standard library functions, we can define or create our own functions while writing the program. Such functions are called user-defined functions. Thus, a function defined to achieve some task as per the programmer's requirement is called a user-defined function. How do you create a user-defined function? I have already shown this to you. You use the keyword def, which is a short form for define. We have done this syntax with you. The item is enclosed in box brackets. They are called parameters and they are optional. A function may or may not have parameters, and a function may or may not return a value. Function header always ends with a semicolon, just like for loop, while loop, if loop, all these end with a semicolon. Function name should be unique, and rules for naming variables also apply to function names. The statements outside the function indentation are not considered as a part of the function. Now, the function to add two numbers. We need to accept two numbers, calculate their sum, display the sum. So how we have done it? We have made a function called define add num. This practice you will do, okay? Then you're taking first number, you're taking second number, you're doing the sum, and then you're printing it. All this inside the function. All this that you used to do outside, now you're doing in a function. And you're going to call the function using the name of the function, that is add num. Okay, so to execute the function, we need to call the function. The function can be called in the program by writing the function name, followed by open bracket, close bracket. Open bracket, close bracket can be empty if the function doesn't take any parameters. If it takes parameters, you have to write the parameters over here. Now, let's talk about the arguments and parameters. Now, in this example that we just saw, the numbers were accepted from the user within the function itself. But, like I have shown you all before, it is possible that we take or receive the values outside the function. So, an argument is a value passed to the function during the function call, and it is received in a corresponding parameter defined in the function. So, program to find the sum of first n natural numbers. Over here, we are defining a function. We are saying sum equals to, we have done this, you know, how to do it, you all already know. The only thing is n over here. So over here, n we either take from the user, or if I have told you all, okay, find the first 20 or find the first 30, then you just pass the number 30. So like that, when you make a function, it becomes easier to pass the program. This is another program that you will practice. Okay. I'm leaving it here on the screen so you can take a screenshot and practice it. I have already shared this file with you all. You can open the file, go to this page and practice it too. Now, so let us, what is this? Both arguments and parameters refers to the same value. Yes. So I have already shown this example today only to you all. They're taking a value of n from the user and they're saving it in the word or the variable num. And when we are calling for this function, when we are calling for the function, we are passing the word num. But when the function is executed, it converts it to n. So n, num is the argument that we are passing along with the name of the function, and parameter is over here. That is when you define the function, what you write over here is parameter. So n is the parameter, num is the argument, and both of them have, or they refer to the same value, they point to the same value. Okay. Now, write a program using user-defined function that accepts an integer and increments the value by 5. Also display the ID of argument before the function call. ID is another function I had shown you all. I had explained to you all at that time. ID, type, these were two functions that we had used with variables. to see the memory location and to explain to you all how the memories, how the variables save memories in Python, how it is different from other codes. It was done in the Python fundamental chapter. So over here, what is this? What are they saying is you display the ID of argument and ID of parameter both before increment and after increment and check if it is same or not. So here the number and num have the same ID, but the ID of num has then changed. Because what happens, I'll explain to you here only. Okay. So let's look at this. When you look at this kind of a program which has a function in it, it starts from here, okay. When you look at this particular program which has a function in it, remember the execution, the code execution does not start from here. It does not start from here. It will start outside where the function ends over here. So it will start from here. We'll say number equals to integer, input, enter a number. So let's say we enter the number 8. Print ID of argument number is, so whatever some ID, let's say 100 or whatever, is printed over here. Then we are going to increase value, that is the name of my function. And I'm passing the word number over here. So when it goes here, this time it will be called. It will come here and now my number will change to num. Now we are going to print the ID of num. Remember, number is outside the function, so it can be used inside. Num is inside the function, it cannot be used outside. So ID of num before increment. So we will print the ID, whatever this is, and it will be the same as 100. Now you're changing the value of num. Now num is going to become 8 plus 5 is going to become 13. So now it will not point to 100. So ID of num after increment will be, let's say, 105. But before increment it will be 100. Also, if you come out and you print the ID of number again, number still has the value 8 in it. So it will still print ID as 100. But the word num, the value in the word num has changed because of this line. Num equals to num plus 5. So the ID of num will be different. Clear? If not clear, run the program and see it. Next, they've even explained it to you. Okay. Another work you're going to do is write a program using a user-defined function myMean to calculate the mean of floating values stored in a list. So in this, you're using a list data type that we have not learned still. So I request you to do it exactly like it is on your screen or in your text. And you can change the numbers inside here, making sure you are, separating them with a comma. I'll explain this to you only when we do list, not right now. Next, write a program using a user-defined function, calculate factorial, to calculate and display the factorial of a number num passed as an argument. We have done factorial before, so you just have to change it into a function mode and show it. Okay, we have done factorial before, correct? Yes, we have done factorial right here. You just have to change it into a function mode and show it. All right. String as a parameter. Sometimes we can take strings as a parameter also. So here we are saying define full name, and we are just saying hello Janisha or hello Manas Tiru, whatever, or hello Janvi Nair. I'm sorry, Manas, I do not remember your surname. So whatever it is, or hello Amitabh Bachchan, or hello Salman Khan, whatever. Just taking the first name, and what are we doing is we're taking the first name and last name separately from the user, and we are just going to be displaying it together in one line. So In that, when we are passing the value to the function now, over here, when we are passing the value to the function, this first and last, they don't have integer values, they have string values. So they are showing you the difference over here. Okay. Then we come to default parameter. Default parameter means, for example, let's say you are calculating a radius of a program of a circle or something like that. In that, you know that the radius should be 2.5 minimum. Like, you don't want the user to leave it null, so you want minimum 2.5, but you will ask the user enter radius, and there are chances that the user may not enter anything. So in that case, you don't want to not calculate the value of the area of the circle. So what you do is you keep a default value that if nothing is provided, you are going to use this. So that is a default parameter. Python allows assigning a default value to the parameter. A default value is a value that is pre-decided and assigned to the parameter when the function call does not have its corresponding argument. So the example that they're using here is a mixed fraction. When the fraction formed is not a proper fraction, the default value of denominator will become 1. Okay, so what is the requirements? So you will input the numerator and denominator from user. Then you will check if the numerator and denominator form a proper fraction. If they do not form a proper fraction, then you're going to call mixed fraction. And mixed fraction will display a mixed fraction only when the fraction does not evaluate to a whole number. So how have they made it a default parameter? Very important over here. How do they make it a default parameter? Look over here. Especially look at this part. Can you see the value assigned? Denominator equals to 1. That means if denominator is not provided to you, you will use 1. But if denominator is provided to you, you will not use 1. Okay? So let's say how they are calling it. How are they calling that function? How are they calling this function? Let's see. So over here they are saying, not here. Okay. Mixed fraction. Okay. So they are checking. They are taking the input from the user. They're taking numerator. They're taking denominator. And they're saying if the numerator is more than denominator, okay, then it is improper. Then it is improper, and if it is improper, you're going to call for mixed fractions. This improper is a part of the condition, comment. It's just gone to the next line. It's a part of this comment. So if the numerator is higher than denominator, then go to mixed fractions. And in mixed fractions, we are passing the number and we are passing the denominator. So it will go here and it will calculate the remainder, and it will check if the fraction does not evaluate to a whole number. So it is going to say if remainder does not equal to 0, then quotient equals to this, and you're going to print the mixed fraction, quotient, remainder, and denominator. Otherwise, that means if it's a proper fraction, you will print it is a proper fraction. So, like you can see, you entered 17 upon 2. The mixed fraction is 8.5. This is very, very important. I want you to practice this particular program for sure. Okay. And now, we will do functions with returning values next time. You all have already known how, you all have already seen how we are returning values and how we save the returned values in a variable. I think we'll do returning values today. Wait. So we've seen just like a function may or may not have parameters, a function may or may not have a value. So the return statement returns the value from the function. So the functions that perform the calculation and display the results in themselves will not require return values. But suppose they are not displaying the result in themselves, then they need to return a value. Okay. Sometimes we need to send values from one function to another function or from one function to the main program. And this is done using the return statement. The return statement does the following. It controls the calling of the function and it returns the value or none. So in this particular program, we are using a function called calculate power that accepts the base and exponent as arguments and returns the value. So over here, you can see this calculate power is there. Sorry, something is wrong. Okay. Yeah, I'm talking of this area. So what is happening over here is we are taking the number and we're taking the power from the user. We are saying result equals to 1 because we have to multiply. Anything multiplied by 1 remains 1. For I in the range from 1 to power plus 1, result equals to result multiplied by the number. Finally, whatever result you are getting, you want to return it back. So where does it go? Where is this called? Where is the calc power called? Now, understand one thing. There are two things in whichever programs have functions. There are two things. One is function. The other is the main program or where the execution is happening. The execution is happening over here. Okay. So what happens now? Whenever this particular name of this function will be there, wherever this function name will come, the program flow goes here and it comes back over there only. So when it comes back with the result, because we have returned, let's say the result is 100 or whatever, it goes and it saves itself in the variable that was used to call it. So it will go and save in answer. And finally, we will have a value over here. Okay. So whenever functions are there, there are two parts. One is the function where we have just defined, we have just named a set of lines as, we've just given name to a set of lines, a set of instructions that has to be executed together. We just named it, but we have not called it anywhere. For example, if I have a class and I have divided the class into 5 groups, group A, group B, group C, group D, group E, but just making the groups, nothing happens. When I call the group, that time they will come. Similarly, when you call the function, only that time the function will work. It will do its work. Otherwise, it will not do its work. Okay, so I think I have given you all lots of programs to practice today compared to yesterday when I gave you nothing. So please don't complain. With this, I'm going to end today's class. We've done quite a lot today, and this week will be heavy because I want to finish this chapter with you all so that we can practice more. Okay. So we have learned that a function may or may not have parameters. Function may or may not have any return values. And as per our requirement, we can make functions in any of the following ways. Functions with no arguments and no return values. Functions with no arguments but with return values. And functions with arguments and no return values. Okay, and functions with arguments and return values. So either no arguments, no return values, or with arguments and with return values, or with arguments, no return values, or no arguments and return values. All 4 types we can make functions as and when we want in our way. So with this, I end today's class. Practice all these programs up till now. Understand the flow, how is it happening in your mind, and to recheck what you are thinking is right or wrong. It's okay to change values of words a little bit, change the variable names to understand what you are thinking. Okay, with this I end today's class. Lots of work. Please practice it and be ready for next class. With this I end today's class. Stay home, stay safe, take care, keep learning. Thank you.